Woohoo! Welcome back. Tonight we're going to be working with a couple more examples of average rate of change. And the first example says, given the following chart, lovely little chart, between which two x values did y increase the most? Is this where the average rate of change was greatest? If not, where was the average rate of change greatest? And so since it says between which two x values did y increase the most, let's look at how y is changing. For example, to go from 4 to 5, y went up by 1. To go from 5 to 7, went up by 2. To go from 7 to 8, went up by 1. 8 to 11, it went up by 3. From 11 to 12, it went up by 1. And from 12 to 13, it went up by 1. And so this was the biggest change. So that happened between x equals 4 and x equals 6. Okay. So is this where the average rate of change was greatest? Well, not necessarily, because if we look over here, x goes up by 1, 2 to 3, x goes up by 1, 3 to 4, x goes up by 1, 4 to 6, x went up by 2. So we're missing a piece of information here. So we don't actually know what happens when x is 5, which is interesting. And then 6 to 7 is back to 1, and 7 to 8 is back to 1. So what are our average rates of change? Okay, so over here, if we have average rate of change, and I'll remind you that in this case, this is delta y all over delta x, again, reminiscent of slopes. So as y changes by 1, x changes by 1, and we get 1. For this one, y changes by 2, x changes by 1, so we get 2. This one's also another 1 over 1. For this one, y changed by 3, but x changed by 2. So that's 1.5. This one, y changed by 1, x changed by 1. And then this one also had 1 over 1. So notice that the biggest, and I'm going to write net change, right? This was the biggest change in y. Was this actually the biggest average rate of change? And the answer is no. This is the greatest average rate of change. So let's summarize. The biggest net change in y happened between x equals 4 and x equals 6, right there, between when x equals 4 and x equals 6, and the net change was 3. The greatest average rate of change was actually this one, which happened between x equals and x equals 3. So x equals 2 and x equals 3. And the average rate of change in this case was 2 over 1, which was 2. Because up here, the average rate of change was only 1.5. So again, we've got two different measures that we're looking at. In the one case, if we just look at how much y is changing, this one seems really impressive. But you have to take into consideration that x changed by 2. So when we divide 3 by 2, we only get 1.5. This jump from 5 to 7 was actually the biggest change right there. And that's what average rate of change tells us. It says, don't just look at y, look at the ratio between how y changes compared to how x changes. Delta y over delta x. And of course, the fractions make our little sparkly friend very happy here. Okay, are you guys ready for the very last problem? Dun, dun, dun! Okay, so this problem, this is going to take a little bit, so make sure you've got some snacks, something nice and cozy to drink, and some paper, because you may want to write this down for yourself as well. Find the average rate of change of this function between x equals x, which is a very confusing thing to say, and x equals x plus h. So, what are we looking for? We're looking for g of x plus h minus g of x all over x plus h minus x. And again, how do we know that x plus h goes first? Well, we started with x equals x, so that's the second one. X equals x plus h was written second, so it takes the first spot in the subtraction. And what is this equal to? This is the average rate of change. But we had called this something else before. This is called the difference quotient. Back when we were first learning about functions, this is called the difference quotient. So in this particular case, the difference quotient is an average rate of change. Okay, so we've done this before. This is admittedly a much spicier problem. So let's go ahead and get started. So remember that the pieces here are that we need to find g of x plus h because we already know what g of x is. So g of x plus h, we have to follow this formula. First thing, we need to do the thing, so x plus h squared, right? The first thing is to square something. Then minus 3 times the thing. And then we add 4. And again, if you're looking at that and you're going, wait, what? I'll remind you, the way we did this was, I think, was with little blue boxes. So this is box squared minus 3 times box plus 4. That's the format for this particular function. We're supposed to take thing squared minus 3 times the thing plus 4. Thing squared, in this case x plus h, minus 3 times the thing plus 4. Okay, so now, hopefully you took my advice, and way back when we were talking about functions for the first time, you memorized the square of a binomial, because it's going to be a lot easier. If not, you'll have to remember, and you'll have to say, okay, wait a minute. X plus h, the quantity squared, that's x plus h times x plus h. Okay, so that if we FOIL it, if you don't know the formula, x times x plus x times h plus h times x plus h times h. So then this is going to be x squared plus xh plus, I can reverse this and write xh plus h squared. And then remember that the middle term gets doubled because there are 2 of them, right? The O and the I match. And so we get our formula x squared plus 2xh plus h squared. Again, this is a great thing to memorize only because this thing, the difference quotient, comes up so often. Between now and calculus, you're going to get real good at it. So it's a good time to memorize it. Okay, so we got that over there. So I've got x plus h, the quantity squared, is x squared plus 2xh plus h squared. Then I do minus 3 multiplied times x and minus 3 multiplied times h plus 4. Okay, so this is going to be, and I can't remember the colors I used before, so we're going to use new colors. We're going to do this. That's going to be the blue one. And then remember, up on top, we also have the normal one, just the function as written with the x. And then we got some interesting stuff in the denominator. So g of x plus h minus g of x all over x plus h minus x. Okay, so that's going to be the blue one first. And again, this is a great time to take your paper and turn it sideways. I didn't think to do that, but you can still save yourself. Okay, so I got x squared plus 2xh plus h squared minus 3x minus 3h plus 4. And I'm going to subtract just the plain g of x. X squared minus 3x plus 4 all over x plus h minus x. And again, let me identify, this is the blue piece right there, and this is the yellow piece right here. Okay, so up top, x squared plus 2xh plus h squared minus 3x minus 3h plus 4. Remember, the minus goes through to everybody. Either you're thinking of it as an opposite of, or you're thinking of it as a -1. So I get the opposite of x squared plus 3x minus 4. And down in the denominator, x plus h minus x is just x plus h minus x. Okay, we're in it. Just remember, write big, go slowly, take breaks if you need to. Now, I need to identify what cancels. And remember, the hint I gave you back then was that everything that doesn't have an h will cancel. This will work. So I've got an x squared and a minus x squared. They cancel. I've got a minus 3x and a plus 3x. They cancel. And then I've got a plus 4 and a minus 4, and they cancel. So up top, I'm left just with the h terms. So I've got 2xh plus h squared, cancel, cancel, minus 3h, cancel, 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 cancel. And that's it. In fact, I gave myself way more room than I needed. Okay, down in the denominator, x minus x, that cancels, so all I have is h. And remember the next step. I had said, okay, when you get to this point, there are a couple ways to do this. The most recommended way to do this is to factor out the h. So I'm going to pull an h out of all three terms. So I have 2x left in the first one, a single h in the second one, and a minus 3 in the last. And then I'm going to take my red pen of destiny, cancel the h's, and I get 2x plus h minus 3. And you may or may not remember, but I told you that is a rabbit fur, but that is the derivative, or it will be once we do a little bit more magic on it. There's one more step that you don't know about yet that you'll learn about in calculus, but basically this is the derivative. And what is the derivative? The derivative is the average rate of change. You're comparing how y changes compared to how x changes. So as x and y are changing in the function, we end up with 2x plus h minus 3. And that's our answer. Now, right now, we're not going to be able to use that for much. We're just going to say, look, it's the answer. And I will say, yes, that is the answer. Very nicely done. Excellent work. And you'll say, thank you so much. And that's it, pretty much. But once we get to calculus, we're going to show you what the next step is. And then basically, that's it. You will own the world at that point. Nothing in the world can ever scare you again, right? Because it's calculus. So what do I recommend? I really recommend that if you don't have this little guy memorized, being able to go from here to here is going to be very important. So put that on a to-do list somewhere. Granted, if you are someone you know that it's going to be really hard for you to memorize it, that's fine. Just remember that you can multiply out using FOIL. And otherwise, you guys are done with the section 2.4. Yay! You're amazing. And we will come back and do some more work with functions. But right now, give yourself a break. You know, have a little dance party, celebrate yourself, know that you're awesome and amazing. And that I will, well, I'll see you in the next video. And if you have any questions, please don't hesitate to ask. And otherwise, just, you know, make sure you math on.